So we're going to talk about half-life. You've probably heard this word before, but it's basically in referring to something that has to do with radioactive or radioactivity. Okay. So the half-life of a radioactive sample happens when half the total number of atoms in the initial sample are gone. So when we're talking about a sample, we're talking about like maybe a piece of metal or something, right? That metal has a certain number of atoms in it. So we're starting with, in this case, we're starting with 100 atoms. After the it gets to, I'm sorry, then the atoms begin to decay. When it gets to 50 atoms, right? Because that's half of 100. The amount of time it takes to go from here to here is the half-life. Okay. There are many half-lives because you can keep going until there's nothing of the original atom left or sample left, right? So the second half-life, when it's from where we start at 50, is half of those atoms. So now we're at 25. Okay. And it's the amount of time that it takes to go from here to here. Okay. And the amount of time from here to here is your first half-life. Your second half-life should be the same amount of time. Okay. So we're going to work with two different ways of doing this. One is looking at a graph. And so this graph shows the radioactive decay of 100 atoms of carbon. Okay. Carbon 14 is what we use to figure out how old something is, right? And so when we look at the graph, we see that it's starting at 100, right? So to determine the half-life of that sample, we need to find the starting amount in the sample. So we figured out that the starting amount is 100 atoms. Okay. How many atoms are left after the first half? So, or the first half-life, sorry. So that means that 100 atoms has to become 50 atoms. So now I'm going to find the 50 atom mark, and I'm going to follow that all the way over to the curve. Okay. And then I'm going to follow it down to where the time axis is. Okay. So 5,700 years, right? Because this is in years. 5,700 years then is the half-life. If you wanted to find the second half-life, you're starting at 50. Half of 50 is 25. You follow that across to the curve, come down. The next one is 11,400. Okay. All right. So that's how you use a graph to find half-life. Let's say that they don't give you a graph. They just give you some data, right? And so here we have data that says sodium 24 has a half-life of 15 hours. Okay. How much sodium 24 will remain in an 18-gram sample after 60 hours? Okay. So the easiest way to do this is to say, okay, I'm starting with 18 grams. My first half-life is when half of 18, so it's 9 grams. That happens at 15 hours, right? They told us that up here. Okay. Then the second half-life happens when we are at 4.5 grams. That happens at 30 hours, right? Because each of these is the same number of hours. The third half-life is then half of the 4.5. So 2.25. Now we're at 45 hours. The fourth half-life is then half of the 2.25, which gives us 1.125 grams. in 60 hours. So now we're at the 60-hour mark. It asks how much is going to be left. 1.125 grams is left.